Well, good morning, good afternoon. Hello to everyone. This is John Clute, K7SYS, and I am your amateur radio moderator for today's ARIS, Amateur Radio on the International Space Station Contact. I'm speaking to you from my home in Sandpoint, Idaho. This event is unusual because two students were involved in each question. Due to California COVID-19 restrictions, the students who wrote the questions will not be asking their own questions. Instead, one fifth grade class comprising a single cohort or group of students is asking all Oakwood questions. Through the help of the amateur radio volunteers and the crew on the ISS, we hope soon to establish an amateur radio contact with the International Space Station as it flies more than 200 miles above the Earth over Italy. This contact will be performed using the Amateur Radio Telebridge Network, a worldwide network of amateur radio ground stations that enables students to contact the ISS. We are joined today by Principal Christine Shales, as well as Norm Thorne, K6UU, the ARIS technical mentor who helped set up this call. We have a short video introducing Oakwood School. Let's all watch that video.
My name is Michelle Helvey, and as the head of Oakwood School, it's my pleasure to welcome you today. We're so excited about this very special opportunity that has been many months in the making. This is a unique assembly, and all of the Oakwood student body are participating today, preschool through 12th grade. During the past year and a half, Oakwood students have participated in many lead-up experiences to this moment. Lower school students have read space books during library time and have had many guest space readers in their classrooms. In preparation for the event, we installed a unidirectional antenna on the roof of the barn. Students have built landers to safely drop payloads. The Astronomy Club helped us witness the transit of Mercury across the sun. Robotics students built lunar bases and considered what it takes to actually land and live on the moon. And the list of activities leading up to today goes on and on. We especially thank those at ARIS and NASA for this remarkable opportunity. We recognize the Oakwood faculty, staff, and community, and especially want to thank Oakwood parents, Dawn and Mike Lyle, who worked very closely with Mrs. Shales, head of school, to make all of this possible today. I invite you to write about this experience later today so you don't forget about it. After all, it isn't every day that you get to talk with an astronaut in a space station. Coming up next, we'll watch a very short video that highlights students as they talk about their experiences at Oakwood School. Thank you for being a part of this today, everyone.
I wake up every morning and I'm really excited to come to school and learn new things.
Classes are challenging, but the faculty is always ready to help you with any problems you have.
All the teachers are really fun and cool, and they give such interesting and cool projects to do.
What makes Oakwood special is that we have a nice theater program.
Oakwood is full of so many talented people and so many supportive teachers that really try to build you up to be the best you can be.
I love Oakwood because of all of its fun activities like Spirit Week and the Freedom Festival.
We help them to be brave and to take chances, and we help them to be their true selves.
The growth and transformation of the school over the last 19 years has been incredible.
I don't think there's any other school I love more than this school.
sky's the limit for them. They could do whatever they want, and we're here to support them.
My classmates are going to be the leaders of our generation.
Back to you, John.
Well, thank you very much. That was an excellent video, and I think it really helps us better understand the students and the setting of Oakwood School. ARIS is an international program supported by amateur radio operators from around the world. Some member organizations of ARIS are the American Radio Relay League, the Worldwide AMSAT, Radio Amateur Satellite Corporation affiliates, as well as space agencies, including the Canadian Space Agency, the European Space Agency, JAXA, the Japanese Space Agency, NASA, the National Aeronautics and Space Administration, and the Russian Space Agency. The amateur radio ground station that will establish contact with the ISS is IK1SLD, located in Casale Monferrato, Italy, and operated by Claudio Ariati. Claudio, please tell us a little bit about your station and how you will handle today's contact with the ISS.
Okay, thank you. Thank you, John, for your presentation. Briefly, our telebridge station is located in Casale Monferrato Airport in northwest of Italy, 100 kilometers from Turin and Milan. When T-minus 30 seconds, I'll go to call Shannon Walker aboard the ISS today, operating with Oscar Romeo 4 India Sierra Sierra call sign. And as soon as signal will be loud and clear, I will invite the students to start with first question. And for students, please don't forget to say over, because this is a very important thing to coordinate the conversation between us and the astronaut. Now I see the International Space Station approaching to Ocean over Brazil, and we have 14 minutes from now to the contact. So microphone back to you, John.
Oh, thank you, Claudio, and thank you for helping us better understand what the contact looks like from your end. As Claudio said, we have about a little less than 14 minutes to contact time. Our contact today is with astronaut Shannon Walker, KD5 Delta X-ray Bravo, who will be using the ISS call sign OR4 ISS. The American Radio Relay League has provided us with a short video that tells us a little bit more about an ARIS contact and how it will all happen. Let's watch this video and see what we can learn.
Hi, my name is Ruth.
And my name is Chris.
You must be pretty excited to talk directly with astronauts on the International Space Station today. While we're waiting for the space station to come over your portion of the sky, let's talk a little bit about how it's going to happen. Of course, Mission Control is in contact with astronauts all the time, using a big radio with lots of fancy equipment.
However, we're going to be using something very different today. We are going to use ham or amateur radio to talk directly to the International Space Station.
When most people hear the word radio, they think of a music radio station, but it's so much more than that. Radio actually refers to the unseen energy that transmits all sorts of signals using electromagnetic waves. At first, people learned how to send signals like Morse code, and then they discovered that you can send so much more, like data, computer signals, and even TV.
Maybe you don't realize it, but you use radio every day. Maybe you watched the TV this morning, or you texted your friends, or maybe even you check social media like Twitter or Instagram.
Let's travel back to space for a minute. Since the beginning of the space age, humans have sent many spacecraft out into the universe. These range from the Hubble Space Telescope orbiting the Earth daily, and the Curiosity rover exploring Mars. We've even sent a long-distance messenger, the Voyager 1, who has traveled outside of our solar system.
Whether it's capturing a great picture of a far-off galaxy or conducting experiments on the space station, radio has to do with all of these. And today, you're going to be using ham radio. Now you might be wondering, what exactly is ham radio?
Amateur or ham radio is a service and a hobby where operators can talk with people around their neighborhoods, their cities, their country, and even around the world. Amateur radio operators require a radio license from the government. They're not that hard to get. I have one. My call sign is KM4LAO.
And mine is KD8YVJ. Our call signs are a way of identifying who we are to other operators. This lets everyone know that we have the proper license to using the radios.
As amateur radio operators, or hams as we are often called, we can talk with others about basically whatever we want, often science or some new radio gadget that we are interested in.
Let's focus back to the space station and your contact today. Many of the astronauts and cosmonauts aboard the space station are licensed ham radio operators. That's why your operators today can contact them. The people here, as well as the astronauts, are licensed to talk to each other, and you are allowed to talk over to their radio.
For our conversation today, we'll need an amateur radio station on the ground, either in this location or somewhere else around the world. We'll also need a radio in the space station.
NA1SS, NA1SS.
You can hear the calls coming. This is November Alpha 1 Sierra Sierra, the International Space Station, over.
On the space station, the radio transceiver is connected to an amateur radio antenna mounted on the outside. One of these antennas will be used today during our contact.
For our side of the contact, we need a good-sized antenna, a signal amplifier, something to make our signal stronger, and a rotator for turning our antenna. We have to keep our antenna pointed right at the International Space Station. And remember, it's moving across the sky and fast.
To aim the antenna properly, we need to track the path of the space station exactly. NASA uses complex systems to track the path of the space station and other orbiting objects.
The satellite tracking program we are using works out a complicated set of mathematics to provide the orbital location of the space station moment by moment as it moves through space. This information is sent into the computer that controls the antenna rotator, which moves the antenna to follow the space station. Maybe some of you have seen or worked with robotics. That's pretty cool stuff. And just like you can program a robot where to go, what to do, and how to get there, you can also program a computer to tell an antenna how to track the space station across the sky.
You know, it took a lot of planning to get this contact. Several weeks ago, the ISS operations team had to figure out when the space station's orbit would pass over this location. Then, they had to talk with the planners at NASA's Johnson Space Center. The crew's time is pretty full, so they were able to find a time that could work for the crew members' schedules. Once they found times that would work both in space and here on the ground, the host organized this contact. And in just a few minutes, you'll be hearing and talking to the astronauts.
Well, it's almost time for your contact. It will be exciting, so good luck with it.
Back to you, John.
All right, very good. So now we know what a contact looks like from the ground end. As you may have noticed, we are using amateur radio in the 2-meter band. For those of you unfamiliar with amateur radio, the downlink is on 145.800 megahertz, which is a little bit above the standard FM band, which stops at 108 megahertz on your radio dial. Astronaut Tim Peake, KG5 BVI, recorded a short video to show us what a contact looks like from the ISS side of the things. Notice while you're watching the video that things seem to be floating inside the ISS in the microgravity environment that is the ISS. Let's watch this video as well.
NA1SS, this is N2SJ.
over. NA2SJ from NA1SS for scheduled contact.
Hi everyone, I'm Tim Peake and welcome aboard the International Space Station, where we're orbiting Earth 16 times every day. One of the most rewarding activities that some astronauts undertake on orbit is to talk to schools using the space station's ham radio. Now these are events that are planned by ISS, which is a worldwide group of amateur radio volunteers who are dedicated to introducing young people and students to science, technology, engineering and mathematics. Now this is the equipment here in the Columbus laboratory, which consists of a handheld radio, a headset, and we also have a ham video unit. Now as the International Space Station orbits above your location, a radio link is established between the ISS and your school. Now because we're travelling at nearly 18,000 miles per hour, which is an incredible 25 times the speed of sound, we usually get about 9 or 10 minutes of good radio contact before losing the signal. So about 5 minutes before the scheduled start time of the contact, I come into the Columbus laboratory and configure the radio so that I'm on the correct channel. And sometimes I'll set up the ham video too. Just before the predicted time, I'll begin to start calling the school using the standard amateur radio calling techniques. For example, if the call sign of your school was GB4 Fun, I would say Golf Bravo 4, Foxtrot Uniform November. This is Golf Bravo 1 Sierra Sierra, listening and standing by. Now at your school, the radio operator will be listening for my call, but may also transmit and try to call me as well. You'll probably have a much more powerful transmitter on the ground than we have up here on board, so I'm likely to hear you before you hear me. Then, once we can hear each other, then comes the best bit, which is actually talking to the students and answering the questions. Once I've answered all the questions, we use the remaining time to say goodbye to each other and end the connection. I'll then spend a few minutes configuring the radio back into a rebroadcast mode, and then I'll go back to my day job, which is of course doing science on board the International Space Station. ARIS is a brilliant opportunity for astronauts to talk to school pupils. It's really rewarding to hear how excited the students are when they're talking to somebody up here in space. And it's a true privilege to be able to inspire our next generation of scientists and engineers through amateur radio.
Back to you, John.
Well, now we've seen a contact both from the ground side and the ISS side. The ISS is presently over the Atlantic Ocean off the west coast of Africa, heading for Europe. As you heard, we're about 200 miles up, traveling at 17,000 miles an hour, more or less, maybe actually a little more. And at that speed, it takes about 10 minutes for the ISS to travel from one horizon to the other horizon. Since the 2-meter band is a line of sight frequency, we will first hear the ISS as it appears over Claudio's horizon. And when it disappears over his horizon 10 minutes later, we will again lose the signal. But that does give us 10 good minutes for the students at Oakwood to ask questions of the astronaut. We are now approximately 3 minutes from contact time. In response to the COVID-19 situation, the ARIS program, just like you, has changed our approach. With you no longer able to go to school as usual, we are using distance learning tools to bring the astronauts to you all as you shelter in place or your homes, or you meet under different circumstances at school. We all need to be as quiet as possible when not speaking. Some of our students today are at home, so remember that if a little sister cries or we hear a dog bark, those are just the sounds of home. We are now, let me see here, we are about a little over 2 minutes away from the contact time, and the ISS is now cruising up the coast of Africa and Spain is coming into the range of possibilities for contact. Please remember that what we're doing on the ISS is an experiment, and as with all experiments, we never quite know the result until the experiment is finished. And please, students, as Claudio has said, please don't forget to say over. This is a really key to him to keep the contact coordinated, and it lets him know when it is time to switch from transmit to receive as we work our way through the contact. It is now about 2 minutes to contact time, and what I'm going to do is turn it over to Claudio so that he may begin his calls as is appropriate. We want to be able to use every minute of those 10 minutes of contact time. Claudio, over to you.
Okay, John. Thank you for the line. The International Space Station is approaching to Italy. We have 40 seconds to the contact. For us over Europe, this will be a beautiful pass, a naked eyes visible pass for our station for Europe. Okay, 21 seconds to the contact. Okay, and calling now. Oscar Romeo 4, India, Sierra, Sierra. This is Italy, Kilo 1, Sierra, Lima Delta, Telebridge Ground Station. Calling for a scheduled Aris contact. Do you copy? Shannon, over.
Kilo 1, Kilo Lima Delta, NA1SS. I read you loud and clear now, over.
Okay, Oscar Romeo 4, India, Sierra, Sierra, IK1, SLD. Good evening, Shannon. Your signal is loud and clear. Today we introduced the Oakwood School in Morgan Hill, California. Are you ready for first question, Shannon, over?
I am ready for questions. Thank you, over.
Okay, go ahead, Marcus.
Marcus from 2nd grade wants to know, what is your favorite place on the ISS? Over.
Marcus, my favorite place is a place that we call a cupola. It is a 360-degree window view of the Earth. Over.
Remy from 3rd grade wants to know, are you currently conducting any experiments yourself? Over.
Remy, it's interesting. The science we do up here are all for researchers on the ground, so none of it is my own science, but I do act as the eyes, ears, and brains for the researchers on the ground. Over.
Lauren from 8th grade wants to know, what was your favorite part of astronaut training? Over.
Lauren, I think my favorite part of the training was actually traveling to all the different countries around the world where we have our partnerships and getting to know people from all those different countries. Over.
Daniel from kindergarten wants to know, what advice do you have for a 6-year-old who wants to be an astronaut? Over.
Daniel, if it's you, I think that's a great idea. I hope all 6-year-olds want to be astronauts. The best thing I can say right now is for you to do well in school. We need scientists. We need people that understand technology. We need engineers. We need mathematicians. So study the STEM sciences, and that will put you on a great path to be an astronaut. Over.
Andrew from 5th grade wants to know, what is the hardest thing you have to do in space? Over.
Andrew, that is an interesting question. I think one of the hardest things I did was get people suited up to go out and do spacewalks. I think it's hard not because it's so difficult to actually do the task, but because it's kind of scary because I'm putting together a spacesuit that's going to keep them alive, and that's a lot of responsibility. Over.
Alice in 1st grade wants to know, is the coronavirus on the ISS and do you need to wear masks? Over.
Alice, thankfully we do not have the coronavirus on the ISS. All the crews were in quarantine for many weeks before we flew up here, so nobody had it. We were all tested. Nobody had the coronavirus, so no masks up here. Over.
Henry M. in 5th grade wants to know, do you and your crewmates play games in space? Over.
Henry, occasionally we play games. Just the other day we were trying to play a card game, although it's really hard to play cards in space because they want to go floating everywhere. Over.
Benno in 4th grade wants to know, can you still do your favorite Earth hobbies on the ISS? Over.
We can do some of them, but one of my favorite hobbies is to cook. And so cooking is a little hard up here because we don't have all the facilities we need to make delicious meals, and all our food comes up from the ground. But we're able to make a few things that are pretty good. Over.
Kate from 8th grade wants to know, are your astronaut outfits customizable? Can you make them different colors? Over.
Kate, I wish our astronaut outfits were customizable. Unfortunately, we have to wear what the ground decides that we're going to wear. Over.
Thomas from 12th grade wants to know, what happens if there is a medical emergency on the ISS? Over.
Thomas, that is an excellent question. All the astronauts and cosmonauts are trained in basic medical procedures. So if there is something that happens, we should be able to take at least the beginning part to get the whoever is injured stable. Beyond that, we've got doctors on the ground that we can call up and talk to, and they can help us. And if somebody is really, really sick or hurt, we would get in our spacecraft and just go home. Over.
Ishan from 7th grade wants to know, who is a role model growing up and how have they helped you succeed in becoming an astronaut? Over.
Ishan, I think my role models were actually my parents. They always encouraged me to do what I wanted and to do well at what I wanted to do. They had very high expectations, and that caused me to have high expectations for myself. And they never told me that girls couldn't be an astronaut, which at the time that I was saying I wanted to be an astronaut, there were no girls that were astronauts. And so I credit them a lot with my success. Over.
Adeline from 3rd grade wants to know, how do you communicate with all the astronauts that come from different countries? Over.
Adeline, we actually have to learn different languages. Mostly everybody speaks English up here, but as an American astronaut, I had to learn the Russian language, and so occasionally I talk to the Russian cosmonauts in Russian, but usually I find that their English is better than my Russian. Over.
Aiden from preschool wants to know, who is your favorite Avenger superhero and why? Over.
You know, that is a difficult question. I think my favorite superhero has to be Wonder Woman. I think she's my favorite because she's just strong and such a good person and really cares about people in the earth. Over.
Noel from 6th grade wants to know, what is the object you miss the most that is on planet Earth? Over.
Noel, that's another tough question. What do I miss the most about Earth? You know, I think it's not an object. I think it is really missing my friends and family. Over.
Miriam in 4th grade wants to know, what was the hardest part of your training and did you think you were going to pass? Over.
Miriam, I would say there's two things that were hard about training for me. One was learning the Russian language because it's very difficult and different from English, and the other is learning how to do spacewalks. That is very physically demanding. At times, I didn't think I was going to pass, but I eventually did. Over.
Anaya from 12th grade wants to know, do the constellations from the space station look different from how they do on Earth? Over.
Anaya, the constellations don't look different, but they're a little bit harder to pick up here because we don't have the atmosphere and pollution and light pollution to worry about. We see a lot more stars, and so it's harder to see the constellations just because it's too busy with other stars. Over.
Charlotte from 1st grade wants to know, we've noticed you use a lot of towels. What if you run out of towels? Over.
So it would be bad if we ran out of towels. But you know what? We've got people that actually keep track of how many towels we use. And every 3 months or so, we get a supply ship with new cargo up here. And so if we're running low on towels, they will send us more towels. Over.
Luke in 7th grade wants to know, although zero gravity sounds fun at first, does it get old after a while? Over.
Look, zero gravity never gets old. Though, I will say that sometimes it gets a little tiresome because it's very easy to lose your stuff if you don't put it down very carefully, because it'll just float away. That's what gets old. But playing in zero gravity never gets old. Over.
Annabelle from 4th grade wants to know, if you were given the chance, would you like to be the first person to Mars? Over.
Annabelle, I think it would be fantastic to be the first person to go to Mars, but I don't think it will be me. I think it'll be somebody that's younger than I am. Maybe you can be the first person to go to Mars. Over.
Arjun from 9th grade wants to know, how do you stay connected with your family on Earth while in space? And how long do you get to talk to or see them? Over.
Arjun, you know, communication is very important. I have email up here, so I can always email my friends and family. We have the ability to make telephone calls from the space station to the ground, so I actually call my husband almost every night. And then once a week, we get a short video conference. That will last about 30 minutes, so I can see my family once a week. Over.
Matthew from 1st grade wants to know, what have you used the Canadarm2 for lately? Over.
Matthew, excellent question. You know, the most recent thing we did with the Canadarm2 was to put a piece of structure and throw it off the side of the space station because we didn't need it anymore. It was amazing to watch. Over.
Dominic from 5th grade wants to know, was the inside of early rockets different from rockets in 2021? Over.
Early rockets were a little bit smaller than the rockets we have now, but the rockets are about the same. But we definitely have a much bigger space station now than early days. Over.
Rena in the 4th grade wants to know, what do you do day to day on the space station? Over.
You know what? Our day-to-day on the space station is always different. Sometimes we do science, sometimes we do maintenance, sometimes we do spacewalks. It just depends on what the ground needs us to do. They dictate everything that we do in space. Over.
Ariana in the 3rd grade wants to know, what government rules do you follow when everyone lives from different countries on the ISS? Over.
Okay, ISS is running out. We have a loss of signal, John.
We would like to thank NASA, Eris, Astronaut Walker, and the ISS crew and all the Oakwood students for making today possible. Our year in space has been an amazing opportunity for us to know that everything is motivated for our opportunity to learn and explore beyond the stars. Thanks for coming, everybody.
We're going to give it here. Okay, well, that was really an interesting contact. We've all just been part of a distance learning activity featuring students from the Oakwood School speaking with Shannon Walker on the International Space Station. On behalf of all the Eris International volunteer teams, sponsors, and space agencies, this is John, Amateur Radio Operator K7SYS, sending my greetings to all of you in traditional amateur radio terms. 7 threes and best wishes. Operator, you may stop the recording at this time and you may terminate the